This question asks us to consider the perimeter and area of the trapezium when it's enlarged. First of all, we have to find the perimeter and area just as it is. The perimeter, of course, we find by just adding together the lengths of all the sides, so 10 plus 7 plus 10 plus 19, and that works out to be 46 centimetres, all added together. The area, the formula for the area of the trapezium is half times the sum of the parallel sides times the distance in between them. So for this trapezium, it's a half 7 plus 19 times 8. Done the calculation beforehand, and so I know that it works out to be 104 square centimetres. So that's its perimeter and area. The second part of the question, we're asked to use our knowledge on scale factors to predict the perimeter and the area if it was scaled by a factor of 2.5. So we're going to make it larger, 2.5 times larger. That means its perimeter will increase by a factor of 2.5 for the enlarged one. The perimeter will equal the old perimeter times by 2.5. You can check my calculations if you like. I get 115 centimetres by getting the old perimeter and multiplying by 2.5, but the area is quite different. The old area was 104, but this time, because it's an area, we increase it by the scale factor of 2.5 squared. So its final area works out to be 650 centimetres squared. The perimeter increases with the scale factor, but the area increases with the square of the scale factor. We're going to check these figures now, because what we're going to do is we're going to consider, and we're going to work out the area using our classic formulas if it was increased by the scale factor. If it was increased by the scale factor of 2.5, each of the sides will be 2.5 times their current size. So this 10 will be 10 times 2.5. It will be 25. 10 times 2.5, and this one will be 25 as well. This side here will be 7 times 2.5. 7 times 2.5 equals 17.5, and 19 times 2.5 equals 47.5, and 8 times 2.5 equals 20. So what I've done is I've got those original dimensions and times them all by 2.5, and here's our enlarged trapezium. What we're going to do is we're going to check its perimeter and area are the same as what we got over here. So its perimeter we can find by adding together all these things, 47.5 plus 25 plus 25 plus 17.5, and if you do that on the calculator, we'll have a go. So it's going to be 47.5 plus 25 plus 25 plus 17.5, and I think I made a mistake there. Let's go again. 47.5 plus 25 I get 115 centimetres. Exactly as we got before when we were in our prediction. And for the area, we're going to use the formula now to do it. So it's a half of the two parallel sides added together, 47.5 plus 17.5, times the distance in between them, 20. And if I do that on the calculator, brackets first, 47.5 plus 17.5 equals, to work out the brackets, I want to times that by half, 0.5, and I want to times it by 20, equals 650, exactly as we predicted using our knowledge of scale factors. Next question here says that a kitchen design is drawn to scalar 1 to 50. By how many times is the area of the kitchen bigger than the area of what it appears on the plan? Now we know its dimensions are, in real life, are going to be 50 times what are on the plan, but what about its area? Well, its area is going to increase not by 50 times, but by 50 squared times. 50 squared is 2,500 times bigger. That's really all we have to say there. And the last question here about sail border. I'll have to move the paper up. It looks pretty right. It's got three similar sails. The smallest has got an area of 12.2. The middle size sail is 20% bigger than the bottom sail. Now if it's 20% bigger, that means 20% added on to its 100% of its size. So all up it's going to be 120% of its original size. You could say that for the middle sail, the scale factor is going to equal 120%. Now 120% can be written as 120 over 100, or 120 divided by 100. You could do it on your calculator or just move the decimal place, equals 1.2. So the scale factor to get that middle size sail is 1.2. All its dimensions are multiplied by 1.2. But what does that do to its area? The area is going to be increased by 1.2 squared. So the area, instead of equaling the original 4.2, we're going to have to multiply it by the scale factor squared. Okay, I've done this beforehand on the calculator. Works out to be 6.05 metres squared. What about the large sail? The scale factor, it's 50% bigger. So that means that it'll be the original size plus 50%, or it'll be 150% of its dimensions. 150% means 150 out of 100. 150 divided by 100 equals 1.5 is the scale factor that we're using. That means its final area is going to be increased not by a scale factor of 1.5 times, but by a scale factor of 1.5 squared times. So the original size is multiplied by 1.5 squared. And if we do that, it works out to be 9.45 square meters.